Let's talk about operators in Java. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Today we will talk about different operators that we have in Java. We have arithmetic operators, assignment operators, comparison operators, logical operators, and bitwise operators. In this video, we will not dive into bitwise operators because it needs its own video, but we will talk about the rest and you will understand how Java operates between different variables and numbers. Okay, arithmetic operators. These can happen between numbers or literals and variables. In these examples, I will just use numbers because we want to talk about the operators themselves. Okay, arithmetic operators is all about doing simple math. So obviously we have plus, minus, multiply, and divide, something that called modulus, increment, and decrease. How this works? If we say 10 plus 2, the result will be 12. So it's just adding two numbers to each other. If we say 10 minus 2, the result will be 8. So it's just removing some number from another number. Multiply is again a simple math operator. So 10 multiply 2 will become 20. Divide is again a simple math operator. 10 divided by 2 will become 5. However, here we have an error that we should take care of. If we divide 10 by 0, we will get an error that is called divide by 0 error. So whenever you want to divide something to a variable, you should check if that variable that you are dividing the number by shouldn't be 0, or else you will get runtime errors. Now, modulus is another thing that is interesting. If we say 10 modulus 2, the result will be 0. Why? It's returning the remainder of the division. Basically, we are dividing 10 by 2 and we are returning the remainder of this division. Now, 10 is an even number, so dividing it by 2, the modulus or the remainder will be 0. However, if we say 10 modulus 3, the result will be 1 because, well, we are dividing 10 by 3 and the remainder will be 1. If we say 10 modulus 4, the result will be 2. That's the remainder of this division. Again, if we say 10 modulus 5, the result will be 0. So it's just returning the remainder of the division. Now, plus plus is like we say 10 plus plus. Normally, you will use plus plus on variables and it will increment it by 1, so the result will be 11. Again, decrement removes 1 from the digit, so it will become 9. These two normally is being used on variables and not on the numbers directly. So you can do any one of these arithmetic operators on variables. However, there is a very important thing to talk here, and that is the order of operation. Not everything will work as you write. In the order of operation, we will have multiply, divide, and the remainder or modulus being calculated first. Then we will go for plus, minus, increment, and decrement. And we also go from left to right. So if I write something like this, 10 plus 2 divided by 2 multiplied by 5 minus 5. What will be the result? Well, the PC will start from left to right, ignoring the plus because we have a divide here. So the result will be at the first pass will become 10 plus 1 multiplied by 5 minus 5. Again, it will read from left to right and give the higher priority to this multiply. So 1 multiplied by 5 will become 5. So we say 10 plus 5 minus 5. Now we are in a stage that everything has equal priority. Here the computer starts from left to right and do the math. So 10 plus 5 will become 15 minus 5, and at the last pass it will do the subtraction and the result will become 10. Now what if I would want to do this plus first and then the divide? This is where you will use parentheses. So we say 10 plus 2, closing the parenthesis, divided by 2 multiplied by 5 minus 5. Now here the parenthesis takes the first order and priority. So the computer will do anything that is inside that parenthesis. So it will become 12. Then we have the division, 2 multiplied by 5 minus 5. And the rest is exactly as above. So reading from left to right, giving priority to divide and multiply. So it will become 12 divided by 2 will become 6 multiplied by 5 minus 5. Then the multiplication happens, so it becomes 30 minus 5, and the final calculation will give you 25. Now, what if I say something like this? Let's do it like this. 10 plus, or actually let's do it by, 10 plus, let's do it this way. Open parenthesis, 2 divided by, open parenthesis, 2 multiplied 5, close parenthesis, then again opening a parenthesis before that, minus 5, closing this parenthesis, and the last one. So we let's count the parenthesis, 1 opening, 2, 3 openings, 3 closing. Okay, how this will work? The computer will start with the most internal parenthesis and will do the math there. So it will become 2 multiplied 5 will become 10. So if we copy this guy, paste it, the computer will calculate this part first, it will become 10. Then again, the innermost parenthesis will become this. So if we copy this whole thing, paste it, computer will calculate this part, 10 minus 5 will become 5. Then it will do this part, and actually if we don't have this parenthesis, it doesn't matter now, because the order of operations gives higher priority to this division. So it will become 10 plus 2 divided by 5 will become 0.4. Now, assuming that we are accepting floats or doubles or anything with precisions, that will be the result, and the final result will be 10.4. And this is the order of operations. Okay, so I will cut it from here and put it here. And these are different examples. So if you want to have a very precise order of calculating the math, you should use parentheses. And remember, the parentheses come in pairs, so any opening should have one closing. Now, let's go to assigning operators or assignment operators. These are easier because they happen normally on variables and when you want to do something with variables. So let's say that we have something like this. We say int x equals 10. Here we are immediately using an assignment variable and we are using equal. So we are putting 10 into x, okay? Then we can use other assignments. So we can assign x to become a different number, like 5. And then we can change it. So we say x plus equal. Now plus equal, for example, 2. Here what we are saying is that saying x equals to x plus 2. So the result here, knowing that x was 5, plusing by 2 will become 7. The next assignment is minus. So x minus equals 2 is equivalent of saying x equals to x minus 2. The result will become 5. X multiply equals 2 is equivalent of saying x equals x multiplied by 2. Now x being 5 multiplied by 2 will become 10. X divide equals 2 means that x equals x divided by 2. The result will become back to 5. And finally, we have x modulus equals, let's say 5. Now we are asking for x equals to x modulus 5. The remainder of 5 divided by 5 will become 0, so x now is 0. So these are assignment operators: equals, plus equal, minus equal, multiply equal, divide equal, modulus equal. Comparison operators are being used when you want to have logical decision making between numbers. Okay, so let's say that we say x equals 5, and then we say int y equals to 3. Okay, so we have two variables. Let's say a and b here so that we don't get any errors. Now we can use system.out.println, and if we say x equals equal, so I'm typing two equals. Because I'm using a special font, it shows it like this without any spaces between them, or I should say a equal b. Now if I run the program, it prints false for me because a is not equal to 3. Okay, 5 is not equal to 3. So having two equals, equal space equal, you remove this space. Okay, equal, or we can say not equal. Pay attention, not equal. And if I remove the space, my special font shows it like this. So if I print not equal, it will become true. If I say a greater than b, now 5 is greater than 3, and the result will be true. If I say a smaller than b, so we have greater, smaller, it will become false. I can ask if a is greater or equal, it will become like that. This is my special fonts again. So you will type greater and equal without a space. My special font will show it like that. So a greater or equal b, 5 is greater than 3, so it's not equal, but it's greater. Logically, it will become true. If I say a smaller or equal, and I remove this space. So the next one is smaller equal without the space. It's false because 5 is not equal to 3 and 5 is not smaller than 3. So these are comparison operators. The result will be either true or false. Now we have logical operators. These are the last ones that I will talk about. Okay, we will combine two different comparison operators with a logic. For example, we are saying if a is greater than b, that's the true, so the first one is true, but we want to do something else here. We want to say and something. Here we say and with two and characters. Now x is 0 here, remember? We say x equal to 0. So true, and the result will be true. What if we want to say or? Now, if I say x it does not equals to 0, the result will be false because the and operator will not work like this. However, if I say pipe, it will become an or statement. So here we say true or false. Now it will become true. So we have and, we have or, and then we have not. So if I say system out print not true, okay? So not true means false. So the result will be, of course, false. Now you will not use not true like this, but when you have a comparison operator or a logical operator that is assigning the result to a variable, you can say if not the variable, okay? Now let's talk about and operator or operator. And needs both sides to be true. So true and true, the result will be true. If the first param is false and true, the result is false. If the second param is false, again, the result is false. If both parameters are false, again, the result is false. Or operator, however, works differently. If either one of these two parameters are true, so true or true, the result is true. False or true, the result will become true. True or false, the result will be true. The only time you will get false is when both sides of the OR operator is false. Now keep in mind, combining these together is a very powerful way of doing logical decision making. And again, the computer will read them from left to right. So here it will calculate this one first, then the second one, and then compare the operators. However, if I do this, putting an AND here, and let's say that A does not equal to 3. So how is it working? Now, it will calculate each one of these statements first. So A greater than B is true. Then we have an OR, then we have a false, then we have an AND, and then we have a true. How it will work? Now, it starts from left to right. It says true or false. The result is true. Then we have and then true. And finally, true and true, the result will become true. However, if we want to do this section first, false and true, we have to use parentheses again. So opening and closing a parenthesis, now it will become like this. This time, computer goes to the innermost parenthesis, solve the logic there, and move outward. And again, the same logic from left to right. So the innermost parenthesis here is false and true. The result is false. So this part will become false. However, now we have true or false. The result is again true. Now let's talk about bitwise operators. I'm not gonna dive into them because you need to know about bit shifting, bit operators, and there are really limited cases that you will use them these days. However, you need to know about them. So we know that a bit is either 0 or 1. We call it bitwise, but in reality, we are working on a byte value type, okay? So we know that a byte is 8 bits, so 0, 0, 0, something like that. Different bitwise operators work on bits in a byte in a special way. So we have AND, we have OR, we have XOR, we have left shift, and we have right shift. These are bit operators. And exactly remember, when you are doing logical operators, you use 2 AND characters or 2 pipes. Because if you use 1, it will become a bitwise operator, not a logical operator. Remember that. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.